Now we want to show you how to actually use Kirchhoff's rules. So there are a couple of steps that we use to implement Kirchhoff's rules. Now, one thing we didn't mention in the last video, what is the point of Kirchhoff's rules? Okay, the point of Kirchhoff's rules is being able to determine what the currents I1, I2, and I3 actually are in a complex circuit. We want to be able to determine what current is flowing through a given branch, right? Now, we're not restricted to 3 branches, right? We could have a obnoxious circuit with 10 branches, and then we would have to solve lots of equations to come up with our 10 currents. So here's the essential idea behind Kirchhoff's rules. I'm going to use the 2 statements we had in the last video, the junction rule and the loop rule, to generate a system of equations that will allow me to then solve for the currents. So in this case, I have 1, 2, 3 currents. If I have 3 currents, that means I have 3 unknowns. I need 3 equations. So I'm going to use the loop rule once, or I'm going to use the junction rule once, and then I'm going to use the loop rule twice. And in general, what you'll find is that for most of your basic Kirchhoff circuits, you will use the junction rule once and then the loop rule twice, all right? So the first step in doing a Kirchhoff problem is to define the direction of your current, okay? So we've already done that, and that should actually be plural. We want to define the direction that the currents are traveling. Now, you are absolutely free to choose the direction of the currents that as you wish, okay? This is actually an arbitrary process. As long as the junction rule is satisfied, as long as at any junction you have your current set up so that as much current enters a junction, that same amount of current exits a junction, you're free to choose the direction of your current as you wish. What will happen is if you get a negative sign at the end of the entire process for one of your currents, it simply means you picked the wrong direction and that the actual current is traveling in the opposite direction, okay? So the first step is to define your currents, and then the second rule is to choose 2 loops that you're then going to apply the loop rule to. So let's see how to set up our system of equations. For this particular circuit, my junction rule define my direction of my currents. The junction rule is going to say that I1 is equal to I2 and I3 because I2 and I3 branch off from I1, and over here they must add back up to I1 as well. So my first equation in this particular circuit is going to be I1 equals I2 plus I3, all right? Now, the loop rule says that the total voltage across a loop must add up to 0. So there are some conventions that we use, okay, when we apply the loop rule. There are a few conventions. The first convention is you start at a particular element, all right? It'll actually be easier just to show you instead of trying to write these down on our confined space here. So what you do is you choose an element in our loop. I typically start with a battery, and then you go around that particular loop until you come back to that particular element, all right? So whatever element in a loop you want to start with, you start with that element, you go in a particular direction, and you come back to that element. So here are the rules. As I'm moving in this loop, all right, if I come to a resistor, as I'm going through the loop, if I come to that resistor and I'm traveling in the direction of the current, right? So for instance, this resistor R2 here, if I move this way through my loop, let's say I choose a clockwise direction, as I come to this circuit component, I'm going through the loop clockwise. As I encounter this resistor, I'm also traveling in the same direction as the current. If you encounter a resistor and you're going in the same direction as the current that you've defined, then that is going to be considered a drop in voltage. In other words, potential energy is getting used by that resistor. If you come to a resistor and you're going through your loop in your closed fashion, and you're going across that resistor opposite the direction of the current you defined, that would be considered a gain in voltage. Okay. Batteries, as I go through this loop, you'll see that I first encounter the negative terminal of the battery, and then I move across the battery to the positive terminal. If I encounter a battery in a loop and I move from the negative to the positive side, that's considered an increase in voltage. So if I were to encounter a battery going the opposite direction, then that would be considered a decrease in voltage. Okay. Now, for the loops that I have set up here and the currents that I have set up, we already have our first equation from the junction rule. Let's now apply the loop rule twice. And let's use this loop here, and let's go clockwise, and let's start at this battery. All right, so if I start at the battery here, because I'm moving clockwise around my loop, I'm going to encounter the negative terminal first and go to the positive terminal, so this is going to be considered an increase in voltage. And I then come to this resistor, and this resistor, I'm traversing it in the direction of the current, so this is going to be a drop in voltage. And remember, we're working with voltages with the loop rules. So what that means is that the voltage across this resistor is just going to be its resistance times the current it's experiencing, and it's going to be a drop. So this is going to be minus R2 I2. And then I'm going to come to this circuit element right here, resistor number 1, and I'm traversing the resistor in the direction of I1, and so this is also going to be a drop in voltage. And the loop rule says that the entire change in voltage must be 0. So all my individual voltage elements must add up to 0, all right? So that's my first loop rule, my second overall equation. And because I have 3 unknowns, I need 1 more equation. And in this case, we can either use the large loop here, or we can use the smaller loop here. I would recommend doing the small loop because it means you have fewer circuit elements. If we were to use the large loop, we would have 3 circuit elements. The small loop only has 2 circuit elements. All right. So let's start here at this point right here and go again clockwise around my loop. All right. So if I start here, I traverse resistor 3 in the direction of I3. So this is going to be a drop in current, or a drop in voltage rather. And then I come to I2 and I traverse R2 opposite the direction of the current. I'm moving this way across my loop to make it a closed loop, but I2 is moving this way. So I traverse the resistor this way and the current is that way, so those are opposite each other. This is going to be a gain in voltage. And so now we have 3 equations with 3 unknowns, and I can actually solve these equations. In the next video, we're actually going to put some concrete values with our resistors and see how things turn out. All right, so stick with us, we're almost done.